morning to all. Today we are going to discuss about Coulomb's law and its applications. Coulomb's law states that the force between two point charges is directly proportional to the product of those charges and inversely proportional to the square of the distance between them. So for this, let us consider 2 point charges, that is Q1 and Q2. These two charges are separated by a small distance r. Then here Q1 exerts force on Q2 while Q2 exerts force on Q1. We know that the force exerted between those charges is attractive if they are in different polarity. But the force exerted between those charges is repulsive if they are of different polarity, and the force exerted between those charges is attractive if they are of different polarity. So the equation can be written as F is directly proportional to Q1 Q2 divided by R square. So the Coulomb's law states that the force exerted between those charges, those point charges Q1 and Q2 is directly proportional to the product of two charges Q1 and Q2, and it is inversely proportional to the square of the distance between them. Suppose when the distance is increased between Q1 and Q2, force is getting reduced. Now, if we want to make it as an equal symbol, then this becomes, here we have to add a constant of proportionality, then this equation becomes K into Q1 Q2 divided by R square. K represents constant of proportionality. The value of K is 1 divided by 4 pi epsilon, where epsilon represents dielectric constant, but this can be written as epsilon is equal to epsilon naught into epsilon r, where epsilon naught represents the permittivity of free space. Epsilon r represents relative permittivity. But for free space, this equation where the value of epsilon r is equal to 1 for free space, then this equation becomes epsilon is equal to epsilon r. So when we substitute this equation on this one, this becomes F is equal to K into Q1 Q2 divided by R square, where the value of K, what we have is K is equal to 1 divided by 4 pi epsilon. But as I said, the value of epsilon for free space, the value of epsilon becomes epsilon naught. Then the equation is epsilon is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. So F is equal to, from this we get Q1 Q2 divided by 4 pi epsilon naught R square Newton. This is the formula for Coulomb's law. So F is equal to Q1 Q2 divided by 4 pi epsilon naught into R square Newton. Okay, the next we will discuss vector form of Coulomb's law. So for this, let us consider two charges, 2 point charges Q1 and Q2 located at the points having position vectors R1 and R2. This is the origin. So position vector means the distance between origin and charge q1 means this is r, sorry, this is r1, this is r2. Then r2 is a position vector means the distance between. So here we have considered two charges q1 and q2 located at the points having position vectors r1 and r2. Position vector is nothing but the distance between origin and the point on the point charge q1. r2 represents a position vector that means the distance between origin and point charge q2. Okay. So here you know that q1 exerts force on q2 while q2 exerts force on q1. Okay. So first we'll calculate a force on q2. Okay. Force on q2 due to the force exerted by q1 on q2. Along which direction? R bar. Here force exerts on q2 due to q1, so that the direction is r bar 1 2, means the force exerts on q2 point charge due to point charge q1, so that the direction is r bar 1 2. The unit vector along this direction is a bar r 1 2. Okay. So now we will calculate the force on q2 due to q1. So calculate on q2 due to q1, so that the force is F2, that is represented as F2, because we are going to calculate the force on q2. Okay. So by the definition of Coulomb's law, the formula for means the equation for F2 is product of those charges q1 and q2 divided by 4 pi epsilon naught r bar. Here the force exerts on 2 means q2 charge due to q1 charge, so that the direction is r bar 1 2 square into a bar 1 2. Okay. So a bar 1 2 is a unit vector. Unit vector means we know that it is used to represent the proper direction. Okay. So a bar 1 2 can be written as r bar 1 2 divided by modulus of r bar 1 2. Okay. So r bar 1 2, how to write the equation for r bar 1 2? As I said before, here force exerts on q2 due to q1. Okay. So that the position vector for q2 charge what we have represented as r2. Okay. So r2 bar minus, next the position vector for q1 charge is r1 bar divided by modulus of r2 bar minus r1 bar. Okay. So now when we substitute this equation, when we consider this equation, the equation becomes F2 bar is equal to q1 q2 divided by 4 pi epsilon naught r bar 1 2 square into a bar 1 2. This is equation number 1. So the next we are going to calculate, just let us calculate the force on q1 due to q2. Okay. Means q2 exerts force on q1. Okay. So we are going to calculate the force on q1. Then the equation becomes F1 bar. Okay. So F1 bar is equal to q1 q2 divided by 4 pi epsilon naught r bar. Here force on q1. Okay. So that 1 due to q2, then 2 square a bar 2 1. Now the a bar 2 1 can be written as r bar 2 1 divided by modulus of r bar 2 1. This can be here r bar 2 1 force on 1. Okay. On q1 charge due to force on due to q2 charge. So for the position vector for q1 charges r1. So r1 bar minus r2 bar. R2 bar means that's the position vector of q2 divided by modulus of r1 bar minus r2 bar. Now considering R1 bar minus R2 bar. This can be written as minus of R2 bar minus R1 bar. Okay. So that the R1 bar minus R2 bar can be R bar 1 2. So this can be minus of R bar 2 1. So here we get R bar 1 2 is equal to minus R bar 2 1. Okay. So just applying this on this equation number 2. Just consider F1 bar is equation number 2. So on substituting this, by substituting this on this equation, it becomes F1 bar is equal to Q1 Q2 divided by 4 pi epsilon naught R bar square 2 1 into minus of A bar 1 2. Okay. So now this equation is F1 bar. Just refer this F2 bar equation refer equation number 1. So this becomes minus of F2 bar. Okay. So minus of F2 bar. Hence, the force exerted by two charges is equal, but two charges on each other is equal but opposite in direction. So F1 bar, what we get here, F1 bar is equal to minus F2 bar, which means force exerted by two charges on each other is equal but opposite in direction. Okay, next we will discuss about superposition of principle of superposition. If there are more than 2 point charges, each will exert force on one another. Okay. So that to calculate net force on any charge, here we use superposition principle. Okay. So for example, this is origin. Charge Q is surrounded by 3 different charges, 3 point charges, that is Q1, Q2 and Q3. As we discussed before, each will exert force on one another. Okay. Now we are going to calculate the total force, means total net force on charge Q due to Q1, Q2 and Q3. Okay. So first in case 1, the force exerted by Q1 on Q is represented as FQ bar. Okay, FQ bar, because we calculate force on Q due to Q1. So that the force, the equation is F bar Q is equal to, just consider Q1 and Q. Okay, so Q1 Q divided by 4 pi epsilon naught R bar square. Here the direction is Q1 exerts force on Q. Okay. Before that, the position vector for Q is R, then the position vector of Q1 is R1. After that, the position vector of Q2 is R2. Okay. So now Q1 exerts force on Q. Okay. On which direction? R bar Q. Q1 exerts force. Okay. Due to Q1. So that R bar 1Q. Okay. So R bar 1Q square into A bar 1Q. Okay. This is equation number 1. The next, A bar 1Q is R bar 1Q divided by modulus of R bar 1Q. The next, case 2. In case 2, because charge Q is surrounded by 3 different charges. Okay. Then in case 2, Q2 exerts force on Q. So here also we calculate force on charge Q. So that the equation is FQ bar is equal to Q2 exerts force on Q. So that Q2Q divided by 4 pi epsilon naught R bar 2 to Q. Okay. On Q due to charge 2. Q2 charge. So that this is into R bar 2Q square into A bar 2Q. Then again A bar 2Q is R bar 2Q divided by modulus of R bar 2q. Okay. After that, this is equation number 2. The next, Q3 exerts force on Q. On Q, we calculate force. So, F bar Q is equal to Q3 exerts force on Q. So, Q3Q divided by 4 by epsilon naught R bar Q3 to Q. So, Q due to Q3. So, 3Q square A bar 3Q. Okay. Now, A bar 3Q can be R bar 3Q divided by modulus of R bar 3Q. Okay. This is equation number 3. Adding all those equations, we get the total force on Q due to Q1, Q2 and Q3. Okay. So, adding equations 1, 2 and 3, we get the total force on Q due to Q1, Q2 and Q3 is FQ bar is equal to, first, epsilon naught R bar 1 2 square plus divided by 4 pi epsilon naught R bar 3Q square. So, here, so F bar Q, suppose there are n number of charges, the general equation F bar Q is equal to F bar, because here charge Q1 exerts force on Q. Okay. So, that this can be F bar 1Q, then here F bar 2Q. Okay, this can be written as here F bar 3Q. So, by adding these all the three equations, we get the total force on Q is F bar Q is equal to F bar 1Q plus F bar 2Q plus F bar 3Q. Suppose we have n number of charges, then the equation becomes F bar Q is equal to F bar 1Q plus F bar 2Q plus F bar 3Q plus F bar NQ. This is the total force on each charge due to the other charges. Okay, thank you all.